Assalamualaikum and a very good day to everyone that is watching this video. Today, I would like to present about the assignment 1, which is the brute force algorithm. Our group picked the selection sort algorithm. So, what is the selection sort? The selection sort algorithm sort an array by repeatedly finding the minimum element, considering ascending order, from unsorted part and putting it at the beginning. The algorithm maintains two sub-arrays in a given array. The algorithm divides the input list into two parts: a sorted sublist of items, which is built up from left to right at the front of the list, and a sublist of the remaining unsorted items that occupy the rest of the list. Initially, the sorted sublist is empty, and the unsorted sublist is the entire input list. The algorithm proceeds by finding the small list or largest, depending on sorting order, element in the unsorted sublist, exchanging it with the leftmost unsorted element, and moving the sublist boundaries one element to the right. It is different from other sort from similar technique. For example, insertion sort, which we took the next unsorted card and inserted in the right position in the sorted card. Selection sort example. Selection sort works best if the range value is known. For example, an unsorted deck of cards. If you want to sort it, you can use selection sort to sort it in order. Another example included, but not limited to, sorting a numbered chair or anything that involves sorting in general, unless the data is too many, as it will slow down the time it takes for a computer to process it, which I will later explain it in time complexity.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRUL AIZAT bin ROSLI and my metric number is P0319101118. So today, I will explain to all of you about selection sort algorithm with picture diagram. So on the screen, we can see there are unsorted elements in an array, which are 10, 1, 12, 4, and 6. So, in the array, we must remember the left part in array is the minimum value, and the right part is for the maximum value. Okay, right now, 10 is our minimum value. 10 is our current minimum value because it in the left part. So we compare the minimum value, which is 10, with the next element in the array, which is 1. 1 is smaller than 10. So right now, our current minimum value is 1. And then we compare the minimum value, which is 1, with the next element in array, which are 12, 4, and 6. 12, 4, and 6 are greater than 1. So there is no change in the minimum value. So 1 will be swapped with the 10. So we will move to the next part. Okay, right now 10 is our current minimum value. And then 10 will be compared to the next element in the array, which is 12. 12 is greater than 10. So there is no change in our current minimum value. And then we compare to the next element, which is 4. 4 is smaller than 10. So our current minimum value is 4. And we compare to the next element, which is 6. 6 is greater than 4. So there is no change in our current minimum value. So 4 will be swapped with the number 10. Alright, we move to the next part. 12. 12 is our current minimum value. And then we will compare the 12 with the next element in the array, which is 10. 10 is smaller than 12. So our current minimum value for now is 10. And then we compare to the next element, which is 6. 6 is smaller than 10. So 6 will take over the minimum value. So our current minimum value is 6. And then 6 will be swapped with number 12. And then we move to the next part. 10 is our current minimum value. And 10 will be compared to the next element, which is 12. So 12 is greater than 10. So there is no change. So there is no data will be swapped in this case. So we have sorted all the elements in the ascending order with selection sort algorithm concept. So that's all from me. Thank you for watching.
Hello and Assalamualaikum. My name is AHMAD FIRDAUS. So right now, I will explain how to implement selection sort. So selection sort is a sort where it compares between the first index and the second index. The first index will be compared by all of the order index. After it done compare with the order index, it will increment the first index to the second index. And the second index will be compared by all of the order index. And the cycle continue until the last of the index. Okay, first let me declare the first index. To declare this, we need to set the I to at 0 first, and then I less than the size minus 1 and increment the I. Then for the second index, we need to set the index equal to I plus 1 and the index less than the size of the array and increment it. Okay, now we're done. So it will compare between two index. To compare it, we do the if statement. If A at index J is smaller than A at index I, then it will swap the A at index J and array at index I. Okay, now let's declare the swap function. The swap function will look like this. So when we run the program with this code, it will sort the random number to ascending order. So over here, I already create some program that can show the visual of the selection sort. So let's run the program. Firstly, the program will insert some random number inside the array, and after that, it will compare between the first index and the second index. If the second index is smaller than the first index, it will become true. When it is true, then two of them will be swapped, and this cycle will continue until the end of the array. So that's all from me. Thank you.
Now that we have already looked at how the coding of the selection sort algorithm works, it is time for me to show the complexity of selection sort. We can actually see how the count work loop inside the coding. As all the coding is the same in selection sort, we can count work loop by the formula given below. The first iteration does n minus 1 comparison, the second does n minus 2, and so on. It costs one swap per iteration. The number of time done in outer loop is equal to the number of time done in inner loop. Thus, n minus 1 plus n minus 2 plus n minus 3 plus so on plus 3 plus 2 plus 1. The sum that you will get is n in bracket n minus 1 divided by 2, and you will get the time complexity of O n square. For the complexity of selection sort, the worst case time complexity is O n square, and the average case time complexity is O n square. The best case time complexity is also O n square. The space complexity is O1. For the swap, the worst, average, and best is the same, which is O n. O n2 O n square is not a good time complexity for sorting lists when it comes to large input size. So selection sort work best if the data is small. Since its space complexity is O1, it means that the space required by the algorithm to process the data is constant, so it does not grow with the size of the data on which the algorithm is operating. This is good in a way you can use a constant amount of memory in a data space. Best case is always O(n squared) since there is 2 loops inside coding. The selection sort has the property of minimizing the number of swaps. In application where the cost of swapping item is high, selection sort very well may be the algorithm of choice.
Assalamualaikum warahmatullahi wabarakatuh and good day to all. Today I want to present assignment 1 brute force algorithm. Based on the discussion on the algorithm that our group choose, which is the selection sort algorithm, I have choose the algorithm which is bubble sort algorithm that I think it is better than the algorithm from our discussion, which is the selection sort algorithm. The algorithm that I have choose that I think it is better than selection sort algorithm, which is bubble sort algorithm. What it is the bubble sort algorithm? It is a simple sorting algorithm that repeatedly step through the list, compare adjacent elements and swap them if they are in the wrong order. The pass through the list is repeated until the list is sorted. Then, the algorithm, which is a comparison sort, is named for the way smaller or largest element bubble to the top of the list. Why I think this bubble sort algorithm is better than selection sort algorithm? Because of the advantage. First, the advantage is selection sort surely does have swap than bubble sort. But the thing is, will go over the whole array and sort even if it is already sort. The bubble sort will actually do around n comparison when the array is sorted, which make it have O(n) time comparison. It will also be faster when the array is nearly sorted, which on average result in the bubble sort being faster. Second, the advantage is it is very easy to write correctly. If you are doing something quick and dirty, then it might be easier just to use bubble sort. So bubble sort is often used to introduce the concept of algorithm. Third, the advantage is it has the capability to do something most sorting algorithm cannot. In particular, if during a pass there is no exchange, then we know that the list must be sorted. A bubble sort can be modified to stop early if it's found that the list has become sorted. This means that for the list that require just a few passes, a bubble sort may have an advantage in that it will recognize the sorted list and sort. Fourth advantage is actually has the best possible best case sort behavior for a sorted list, because if the list is already sorted, then nothing is changed and you have only needed to iterate through the list once to find that out. And the last of the advantage is it has a low memory consumption because it is an in place sort. And that's all from me. Thank you.